All right, let's find the derivatives of some inverse trig functions. So here we have an inverse trig function, y equals the inverse sine of x. And really, instead of trying to memorize a bunch of new derivatives, we can just rely on some old derivatives and the technique of implicit differentiation. First thing that we should do is rearrange this equation. Since y is equal to the inverse sine of x, by definition, that means that the sine of y is equal to x. Now you notice I have the right triangle over here to kind of help us out, because when I'm looking at y, or sine of y is equal to x, we recognize that y is the angle. And since the sine of y is x, then we have x over 1, opposite over adjacent. And with a little bit of Pythagorean theorem, we can find that this side is 1 minus x squared. All of this is going to be helpful for us in the end, because when we want to find this derivative, dy dx, we're going to want to find it in terms of x. But we have this implicit function, sine of y is equal to x, so we're going to go through implicit differentiation. The derivative of sine is cosine, so the differential is cosine y dy. And the differential of x is dx. We do our 2 steps of division to rearrange. So I'm going to divide by cosine of y to get this one to cancel. And I'm going to divide by dx to bring the dx to the other side. And what we're left with is, of course, dy dx is equal to the reciprocal of cosine y, or secant of y, however you want to look at it. But like we said, we want this derivative to be written in terms of x. That's where that triangle comes into play. Looking at the triangle, where I have my angle y and all my sides filled in, and we can evaluate the cosine of y. Cosine of y is adjacent over hypotenuse, so square root of 1 minus x squared over 1. And there we have our derivative. So let's take a second and just kind of review our steps of how we got through this problem. Our first step was to rearrange that initial equation to get rid of any inverse trig functions. So we're writing a trigonometric equation. The second thing we wanted to do was to use that information from the trig equation to fill in our triangle. Third step was to use implicit differentiation to find that derivative in terms of y. And our last step was to use that triangle, all the information that's in there, to help us rewrite that derivative in terms of x. So let's try a few more, getting good at this process. Remember, our first step is to rewrite the equation to get rid of the inverse trig function. So this would be the cosine of y is 3x. And we bring all that information over to our right triangle. Since we're looking at the cosine of y, y is the angle measure, and the cosine is 3x. So 3x over 1. Use Pythagorean theorem to find the third side, and that will be 1 minus the quantity 3x squared, so 9x squared. Now we go back to our equation and use implicit differentiation to find the derivative. The derivative of cosine is negative sine. So our differential is negative sine of y dy, and derivative of 3x is 3, so the differential is 3 dx. We do our 2 steps of division. We want to divide by dx to get our dy dx on the left, and then also divide by negative sine of y to get that alone. Rewriting our answer, we got dy dx is equal to 3 over negative sine of y. Lastly, we go back to our triangle and grab all the information so that we can rewrite this one in terms of x. We'll still have, I'll call it negative 3 in the numerator. And then the sine of y is going to be opposite over hypotenuse, so that's square root of 1 minus 9x squared. And it's perfectly fine to leave it like this. You do not need to rationalize the denominator. Here we have y is equal to arc tangent of x squared. All right, it's important to realize that when we're talking about arc tangent, that's the same as tangent inverse. So when we rewrite our equation, we're really looking at the tangent of y is equal to x squared. When we go to fill in our triangle, again, y is the angle, but now we see that the tangent of y is x squared. So that means opposite over adjacent is x squared. And when we find that missing side, again, we'll use Pythagorean theorem, but instead of subtracting these perfect squares, we're going to add them. So we'll have 1 squared plus x squared squared, or x to the 4th. Now we go back and find, use implicit differentiation to find dy dx. So derivative of tangent is secant squared. So we have secant squared y dy. And derivative of x squared is 2x, so our differential will be 2x dx. Do our 2 steps of division. Divide by dx, so that we'll have our derivative on the right side. Divide by secant squared to get that derivative alone. So we have dy dx is 2x over secant squared of y. So we look over to our triangle, and we know that secant is the reciprocal of cosine. So cosine was adjacent over hypotenuse. The reciprocal of that is going to be the hypotenuse over the adjacent, or square root of 1 plus x to the 4th. But remember, it's that secant is being squared. So we have to take this and square it. So now we have everything written in terms of x's. We just simplify a little bit, and we'll have 2x in the numerator. And when we square that square root, we'll just have 1 plus x to the 4th in the denominator. Let's try one last example here. Y is equal to arc secant of e to the 2x. And a little nervous because I got this e to the 2x inside. So that's going to be some sort of chain rule happening because we got a function inside a function, which is also inside of secant, or arc secant. But we can get rid of that arc secant by moving it over to the other side. So we really have that the secant of y is equal to e to the 2x. So go ahead and fill in our triangle. So we have the secant of y, so y is our angle. And secant is e to the 2x. So the hypotenuse is e to the 2x. And the adjacent side is 1. We're going to have to use a little Pythagorean theorem to find our missing side. So we'll square the hypotenuse. So I'll just write that as e to the 2x squared minus the adjacent side squared, minus 1. So we can clean that up a little bit. E to the 2x squared, power to a power, we multiply those powers. So we have e to the 4x minus 1, all under the square root. Great. Now we can go through and do implicit differentiation. Derivative of secant is secant tangent, so we'll have secant y, tangent of y, dy. On the right side, like we said, we are going to use chain rule because we have that 2x inside of e to the x. So we take the derivative of the outside function first. Derivative of e is e. So we'll have e to the 2x. And we multiply it by the derivative of the inside function. Derivative of 2x is 2. And then attach our differential, dx. Now we're going to do our 2 steps of division. All right, so we're going to want to divide by dx. Get rid of that. Get our derivative on the left. And then we'll divide by secant tangent to get rid of that. So we're looking at dy dx is 2e to the 2x over secant y tangent y. Last step is to go back to our triangle, change all those trig functions to rewrite them in terms of x. So we'll have dy dx is equal to 2e to the 2x in the numerator. In the denominator, our secant is e to the 2x over 1, so e to the 2x. And our tangent is going to be opposite over adjacent, so just that square root over 1. So square root of e to the 4x minus 1. And that's our process for trying to find the derivatives of inverse trig functions.